Hey guys, this is question number 11, and in this questions we'll talk about diffractions pattern associated with the double slit experiment. In question number 5, already we have talked about the diffractions pattern associated with a single slit. So in these questions we'll talk about the diffraction pattern associated with the double slit. So let's see what we have to solve in these questions. So in this question it is written that the diffractions pattern due to a double slit experiment with two identical slits is recorded in an infrared laser radiations of wavelength 1.2 micrometer on a special prepared photography plate at a distance of 1.8 meter from the center of the slits. The photography of the observed diffractions pattern is given below. So this is the photograph of the observed diffraction pattern. Now what we have to calculate here, we have to calculate the distance between slits. So let me explain what has been asked in these questions, and for that let me draw a simple diagram of double slit experiment. So in double slit experiment usually we use two identical slits. So in this figure these are the two slits. Okay, these are the two slits, and then we put a lens just behind the slits, convex lens just behind the slits, and then at the focal plane of this lens we put screen. At the focal plane of this lens we put screen, and if we illuminate these slits with a plane wave, when we illuminate these slits with a plane wave, then we see a diffractions pattern on the screen. So this diffraction pattern is known as double slit diffraction pattern. And schematically, it's this interference, this intensity distributions look like this. Okay, this will be look like this. Then, so in these questions, what has been asked that what will be the slit separation? So, what is slit separation? Slit separation is the distance of this first center of the first slide to the second slide. So this distance is called slit separation that we have to calculate here. For that, let me define here. So this opening length of each slits is called the slits width of the individual slits. So this usually defined as B. So B is here the slits width. So what is B here? B is the slits width. B is the slits width. That is the opening length of each slits. Then this center to center distance of the slit is called slit separation, D, that we have to calculate in this question. D is the slit separation. What is D? D is the slit separation, and we have to calculate this slit separation. We have to calculate this slit separation. Okay, so to calculate this slit separation, in this case, from this figure and the information that is given here, so from there, if we want to calculate what will be this slit separation, for that we have to use the concept of missing order. Concept of missing order. And to understand what is the concept of missing order, let me write first intensity distribution of this diffraction pattern. Intensity distribution of the diffraction pattern. So for that, let me assume that the intensity of the incident wave is I naught, and the wavelength of the incident wave, so let's say lambda, and consider a point on the screen. Let's say this point, this is a point, let's say P point. And if we added the center of the slits and this point, so the angle between this vertical line and this line is called the diffraction angle. So this is the diffraction angle associated with this position. So if we want to write the intensity distribution on the screen at this position, then we can write this intensity I. So the intensity of the diffracted wave at point P is I is equals to 4 times of I naught sine square beta divided by beta square into cos square alpha into cos square alpha, where this beta is equals to pi d, sorry, not pi d, beta is equals to pi b sine theta divided by lambda. So what is b here? B is the slits width of individual slits, and lambda is the wavelength of the incident wave, and theta is the diffraction angle at that point P. And what is alpha? Alpha is pi t sine theta divided by lambda. What is d here? D is the slit separation. D is the slit separation. Okay. So what has been written here? So this is the intensity associated with the diffraction pattern of double slit, where I naught is the intensity of incident wave and alpha and beta is given by these two parameter. And then you can compare with the single slit diffraction pattern and the intensity interference pattern associated with 2-point source with this intensity pattern. And if you compare this intensity pattern with the single slit diffraction pattern and two-point source interference pattern, one you can say that this first term sine square beta divided by beta, this will represent a diffraction pattern associated with a single slit, where the remaining term 4 I naught into cos square alpha, this will represent a interference pattern associated with 2-point source. So in next page, let me just define these two terms. So for that, let me again write the intensity distribution at point P. I is equals to 4 times of I naught sine square beta divided by beta square into cos square alpha. Into cos square alpha, where this first term, this term, represent the diffraction term. So this represent diffraction pattern of single slit diffraction pattern of single slit of slits with B, and the second term, this term, represent the interference pattern of 2-point source separated by a distance d. 2-point source separated by a distance d. Okay, so the intensity distribution term associated with the double slit experiment is consist of two different terms, where one term is associated with the diffraction pattern of single slit and another term is represent the interference pattern of 2-point source. 2-point source. Now we have to understood what is the missing order. What is the concept of missing order? For that we will use this idea. When this diffraction, at what point we'll get this diffraction minima and what point we get this interference maxima. So use this condition here. So right here, concept of missing order. Concept of missing order. Concept of missing order. So for that, what we have to do, first we have to find out the condition of interference maxima. That means when this term will be maximum. For which value of alpha or which value of this theta, that diffraction angle, this interference term will give you maximum intensity. So right here, for interference maxima, for interference maxima, so what will be condition of interference maxima? When this cos square alpha term will be 1. And when it will be 1? When alpha is equals to m pi. Alpha is equals to m pi, where m is the integer multiple. Plus minus 1, plus minus 2, plus minus 3 is 1. And what is the value of alpha? Alpha, we have written alpha is equals to pi d sine theta divided by lambda. So that is equals to m pi. So from here we can find out what will be the angular position of mth order interference maxima. Mth order interference maxima, and that will be m lambda divided by d. M lambda divided by d. So this will give you the angular position of mth order interference maxima. Mth order interference maxima. Now second condition that we have to calculate to understand the missing order, that is called condition for diffraction minima. That means when this term will be this term sine square beta divided by beta, this term will be minimum. So right here, condition for diffraction minima. diffraction minima. So what will be that condition? When sine beta will be 0 but beta not equals to 0. Beta not equals to 0 but sine beta equals to 0, then only this diffraction term will give you 0, that is minimum intensity. So when this sine beta will be 0, when beta is equals to n pi. What is n here? N is the integer number, but this n cannot be 0. Plus minus 1 plus minus 2. If n 0, then beta will be 0, but beta not equals to 0, then only we get the diffraction minima. Okay. Now what is the value of beta? Beta we have written pi v sine theta divided by lambda. So this is equals to n pi. So from here we can calculate position of nth order diffraction minima, and this is equals to what we'll get lambda n lambda divided by b. N lambda divided by b. So this is the position of nth order diffraction minima. Nth order diffraction minima. Now the question says, if this interference maxima and this diffraction minima occur at the same angular position, then what will be this product of these two terms? One is maxima but another is 0. So this give you intensity 0. That means this interference maxima will disappear from the diffraction pattern. So this concept is called missing order. So if mth order interference maxima and the nth order diffraction minima occurs at the same position, then this mth order interference maxima will disappear from the experiment, from the from the diffraction pattern. So this phenomena is known as concept of missing order. So this is the concept of missing order, and from this definition we can calculate what will be the missing order of a double slit diffraction pattern. So for that, what we have to do, we have to make these two equation equal. Left hand side, if the theta is the same value for interference maxima and diffraction minima, then both equations sine theta will be same. If the sine theta is same, then the right side should be same. So from here we can write for missing order, what we can write, right side of this both equation we can make equal. When you make them equal, what we'll get? We'll get m lambda divided by d equals to n lambda divided by b. M lambda divided by d is equals to n lambda divided by b. So from there, lambda will cancel out from both sides. So what we'll get? We'll get missing order m is equals to d divided by b into n. But what is n here? N is the integer number, plus minus 1 plus minus 2 plus minus 3. That means missing order will be integer multiple of this ratio d by b. What is d? D is the slit separation and b is the slits width. So once we know the d and b of an double slit experimental setup, then we can find out what will be the missing order of this diffraction pattern. And if we want to draw this interference pattern of this interference, intensity pattern, intensity distribution associated with any two double slit diffraction pattern. So once we know this missing order, then we can draw how this diffractions pattern will look like. And on the other hand, so for that, what we have to know? We have to know the d by v. So here in this figure, I have assumed that in experimental setup, this d is equals to 4 times of b. There is a slit separations between, that is the distance between two slits is equals to 4 times of slits width of individual slits. So in that case, if we want to draw this intensity distribution of the diffraction pattern, so for that we have two terms. One term is associated with diffraction pattern, single slit diffraction pattern, and another term is intensity distributions pattern. So in the first graph, I have drawn cos square alpha versus alpha graph. So it will be look like this. And then in second graph, I have drawn sine square beta by beta square versus beta. It will look like this. And then when you multiply these two diagram, this will give you the final intensity distribution of a double slit experimental setup. So when I draw this final intensity distribution pattern, here you can see this is the order of interference maxima. This is 0th order, this is first order, second order, third order, fourth order, fifth order, sixth order, seventh order, and eighth order. And but when you finally draw here, you can see here this is the 0th order interference maxima, first order, second order, third order, but fourth order interference maxima is missing here. Why this is disappeared from this interference from this diffraction pattern? Because at this position there is a minima associated with the diffraction pattern. So this term sine square beta term is minima at this point. So that's mean this term is 0, but this term is non-zero. So product of this term will be 0. That's why this fourth order interference maxima is missing here. And also you can see 8th order is also missing here. And then if we draw a higher order, then we'll see 12th will also be missing. From the other side also, here it is -4 and then -8 will also be missing. Okay. So this diffraction pattern, once we know this ratio D and V, then we can draw this diffraction pattern. But sometimes we need to back calculate also. In examiner give us this diffraction pattern. So from this diffraction pattern, we have to find out what will be the missing order of this diffraction pattern. So for that, what we have to do, you have to first count how many interference maxima present between two first order diffraction minima. So in this figure, you can see this is the first order diffraction minima. These are the first order diffraction minima position on the both side in the center. Now what you have to do, you have to count how many interference maxima present between these 2 points. So if we count here, this is 1, 2, 3, 4, 5, 6, 7. So we have 7 interference maxima between 2 first order diffraction minima. So once you count this interference maxima between 2 first order diffraction minima, then you can write missing order. So what will be the missing order in this case? Missing order is equals to number of interference maxima between 2 diffraction minima plus 1 divided by 2. So in this case, there are 7 maxima between 2 diffraction minima. So 7 plus 1 is 8. 8 divided by 2, 4. So 4 will be the missing order. Okay. So both the cases you are getting same result. If you know the D or B ratio, from there you can also calculate missing order. In this case, we have taken this D or B is equals to 4. That means missing order will be 4. And also if you just look at this diffraction pattern, from there if you count the interference maxima between 2 diffraction minima, from there also you can calculate missing order both will give you same result. Okay. So once you know that the diffraction missing order will be the ratio of d divided by v, and that also we can calculate from the looking at the diffraction pattern, then I think we can easily solve this problem. This problem we can solve easily. So look at the diffraction pattern that is given in these questions. So this is the diffraction pattern. So first we have to calculate what will be the missing order from this diffraction pattern. So for that, what we have to identify first, we have to identify what are the two position of first order diffraction minima. So here these are the 2 point. These are the 2 point of first order diffraction minima. This point and this point. These are the 2 point of first order diffraction minima. Then to calculate diffraction minima, what we have to do? So missing order, what we have to do? We have to calculate how many, we have to count how many interference maxima are present between these 2 points. So let's count here. This white point, this white dot here represent the interference maxima. So you have to count how many white dot are present between these 2 points. So let's count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 interference maxima between these 2 points. So that means what will be the missing order in this case? Missing order is equals to n plus 1 divided by 2. What is n? N is the interference maxima between 2 diffraction minima. So in this case, n is 13. So 13 plus 1 divided by 2, that will give you 7. Okay. So from this diffraction pattern, we can say that this experimental setup have a missing order of 7. So once you know the missing order, then we have also get a relation that the missing order must be equal to the ratio of slit separation and individual slits width. So that's mean in this case, d by v, that will be equals to 7. D by v will be 7. Now we have to calculate d. So what will be d here? D will be 7 times of v. D will be 7 times of v. But in this questions, b is also not given. So first we have to calculate what will be the b. What will be value of b. Now how we can calculate what will be the b? For that, take a look on this figure. You know what will be the position of first order diffraction minima from this figure. We can find out what will be the position of first order diffraction minima in this diffraction pattern. So if we write the condition of first order diffraction minima, what will be that condition? We know the condition of diffraction minima of mth order diffraction minima. We have written here. We have written in this slides. You can see here. Here, this is the condition of nth order diffraction minima. So now if we want to calculate first order diffraction minima, then we'll put this n is equals to 1. Then theta we can calculate from the diagram that is given in the questions. From there we can calculate what will be the value of v. From there we can calculate what will be the value of v. So for that, let's just draw simple diagram again here. So this is the center position. Let's say this is the center position, and then we have 2 slits like this, and this is the angular position of first diffraction minima. So this is the angle of theta. In the questions it is written that the distance between source and the screen is 1.8 meter. So this distance is 1.8 meter, and from here to here this distance is 0.6 centimeter. So from the center position to first order diffraction minima, that is this distance. This distance will be half of this length, so it will be 0.3 centimeter. So from this figure, you can see, from this figure we can calculate the value of theta. Once we know the value of theta, we know the condition of diffraction, first order diffraction minima. Condition of first order diffraction minima. Condition of first order minima. And what is that? That is sine theta is equals to lambda divided by b. We have put here n equals to 1 for first order diffraction minima. So from here we can calculate what is the value of v. What will be the value of v? V will be lambda divided by sine theta. And then from this figure, what you can write, sine theta is equals to this length divided by this length. But as you can see here, this length is 0.3 centimeter, but this length is 1.8 meter. So this theta will be very, very less. When this theta is very, very less, so we can write sine theta is equals to theta. And then theta will be 0.3 centimeter. If we convert it into meter, then it will be -2 divided by 1.8 meter. So this will be the value of theta. So if you put this here, so lambda divided by theta, and then if you put the value of theta here, so you'll get value of v. You know the value of lambda also. Lambda is given in the questions 1.2 micrometer, that is 10 to the power -6 meter. So if you put all this value here, from here you will get b is equals to 7.2 into 10 to the power -4 meter. So this is the value of v. Once you know the value of v, then you can put it here. If you put it in this equation here, then we can get the value of d. So what will be the value of d? Therefore, the d is equals to 7 times of this 7.2 into 10 to the power -4 meter, and this will give you 5.04 millimeter. 5.04 millimeter. And this will be the correct answer. This will be the correct answer. So in these questions, what will be the correct option? And option B will be the correct option. Here it is written 5.04 millimeter. So correct options will be option B. Okay. So I hope you understood how to calculate this problem. So for this type of problem, what you have to do, you have to use the concept of missing order. And what is the concept of missing order? That the nth order interference maxima and the nth order diffraction minima must occur at the same position. And from there you can see that missing order will be the ratio of integer multiple of ratio of slit separation and the slits width. So once you know this d divided by v, from there you can calculate missing order, or this missing order if the examiner give the diffraction pattern. So from this missing order, counting the interference maxima between two diffraction minima, you can calculate what will be the missing order associated with this diffraction pattern. Once you know the missing order, then you can put the value of this equal to, you can make this missing order equal to this ratio d divided by v. From there you will get a relations d and v, and to calculate v you have to use the condition for diffraction minima. So this is the way you can solve this type of problem. So I have added one quiz based on this idea that we have discussed in these questions. So check the community section of this of my YouTube channel. There you will get one quiz and try to write your answer on the comment box. Okay, thank you for watching. We'll see you in the next video.